Okay. All right, so we've been talking about area of circles and circumference of circles. Owen, what's the difference between area and circumference?
Circumference is the exterior, and it's how much of the exterior there is. But the area is, I forgot already.
The area is, help him out, Carson.
How much space covers the outside?
Okay, covers, and it's not necessarily the outside, it's covering the surface or the inside of the shape. And we don't go inside of the shape, so it's just basically what covers the shape from the perimeter or the circumference in, right? Okay, circumference is the perimeter of the circle, right? But we can't find the perimeter of a circle because perimeter is the straight sides, and circles don't have any straight sides. I'll hold this for you. Thank you. All right, so circumference we learned was the distance around the circle. There's two different formulas we can use, so we'll write both of those up there. What's one formula we can use?
Pi times diameter.
Okay, pi times diameter, and remember diameter goes all the way across the circle through the center. And Aaron?
2 pi r.
2 pi r. And how are they different? What's the difference between these two?
Radius times 2 is diameter.
Good, so the diameter goes all the way across the circle. The radius just goes from the center to one outside point. So it's half of the diameter. So 2 times radius is the same thing as diameter, okay? All right, and then our area, which we explored with the paper plates last week, we cut up the plate and we spread it out, and we found that it's the same as a rectangle, right? But how do we find its area?
Pi r squared.
Good, pi times radius squared. So when we've completed this circle and we cut it up, and we watched that video where they cut it up into like a bazillion pieces, right, and put it together like teeth, it created a rectangle with a base of, what was the base of that rectangle? The circumference, so 2 pi r, and it was the height was the radius, okay? And when we were able to put those together, we had 2 pi r squared. What do we do with this 2? Tristan, where did this 2 come from? Is this was how much of the circumference of the circle?
It's half.
It was only half, so we had multiplied it by half. And what is 1/2 times 2? 1, so that's where we got the pi r squared. So that was how we derived the formula last week. So we're going to use these two concepts, okay, and help this goat. So this goat, the farmer has tied him onto a shed, and the shed is 6 yards by 4 yards. It's a rectangular shed. And his line here, his chain that he's tied onto, is 3 yards long. So the first step is you're going to sketch the area that you think that the goat may be able to roam, the grass that he's able to eat. Now he can only go as far out as 3 yards. He can't go farther than that because he's connected to the edge of the shed. Next step, you'll calculate the area of the grass that the goat can eat. Again, the shed's going to be in his way, so you'll have to discuss with your group what that means. And then finally, once you've investigated these two, the extra challenge for you is if the length of the rope, or what length of the rope, would allow him to eat 10 square yards of grass, okay? So you'll have to first investigate when he has his 3-yard rope, how much grass he's able to eat. If it's too much, if it's more than 10, maybe his rope needs to be shorter. If it's less than 10, then maybe that rope needs to be longer, okay? So let me give you your sheet that you can investigate. You'll first, again, draw the area, find the area, and then you'll be kind of investigating backwards so that you can eat 10 square yards of rope.
It's already sketched. Where was my shed? Pretty high.
Right there.
Okay, so that just...
Actually, no, wait. It's 6 yards, so that you wouldn't be able to reach there.
What's equal to the bottom?
But because it's 3 yards and this one's entire top.
Say about that. Because it's 3 out of 4
I'd say
yards,
this
and
is
then
a box
3
actually.
out of 6.
It's not even a full box.
It's a circle. Not a box.
Why do you think it might be a circle instead of a rectangle or a square?
It stretches to its farthest point, and its farthest point doesn't continue. This is farther. This point here would be farther than this would be.
Yeah, but the diagonal line should be farther than the
But its road doesn't.
shouldn't be the farthest point.
So what did we learn about a circle? So a circle, each point is equidistant from the center, right? Is every point in a square or a rectangle equal distance from the center?
Yes, except for not in a rectangle, but a square, I think so.
Okay, well let's draw a square on the side and see.
That's a rectangle. So we're to draw a perfect square.
Would it be better maybe if we drew a square with a ruler so we knew each side was equal?
That would be probably the best thing we should do. So we have a point here and a point here.
No, but think about the
Do they all
other
look
side.
to be the
Not
same
just to the
length?
corners. These are the same, but
They appear to be, but they should all be, but the diagonal lines just appear to be bigger.
So would that be equal if they appear to be bigger?
But if they may appear to be, but they might not be.
So let's get a ruler and draw an actual square, right? Then we can measure.
So he could travel and do it. You're right. Okay. You're right. Pardon me. You
Is that diagonal? Is that 3 or 2?
Inches? I think it was 3 inches.
A little bit more.
this is 3/4. That should do it. Yep, it's gonna be perfect. It's gonna be this. So guys, we don't need it right here.
Make sure it's about 90 degrees, right?
This is 3 yards. You know that this is 3 yards.
And then let's measure the center.
So what's half of 3?
1.5. So 1.5 here. And then
And this part is 6.
this point, 1.5. So that's right up here.
Okay, then let's measure some of the distances. Now those are both diagonal distances, so let's measure.
2.
Let's measure from the center to forms a perpendicular relationship. See if that's also 2.
1.5.
So a little bit less, right? So would we say that all the points on a square are equidistant from the center? But all the points on a circle are.
I measured it.
I tried 2, and I ended up with 9.1.
Fairly
I'll do
close.
9.2. We can try 2.5.
Okay.
And
So
get any
2.5.
So what was it?
You say to me
3.6.
You have to figure out what's better for.
Thank you, Lisa. Thank you, Diego. Thank you, Owen. Thank you, Casey. All right, so it looks like most groups are moving along. We determined that what shape is going to make the area that he can eat. What shape are we looking at? A circular shape, okay? And why, again, Owen, can you explain to us why it's not a square?
Because the square has about, for a completely equal square, it's about a 0.5 difference from the length and the diameter.
Okay, so would we say that all points on a square are equidistant from the center?
But they're not.
So would we say that all points on a square are equidistant from the center?
No.
No. But what shape are all the points equidistant from the center? A circle. So we're going to allow the goat to eat in a circular motion around the yard. So he can eat 3 yards away at any point from the place that he's hooked to the shed. Okay. Now, how much of this circle, Emma, is he actually able to eat? Can he eat a full, complete circle?
He can eat 3/4 of it.
Okay, and why can't he eat this fourth?
Because that's in the shed.
Okay, so he's only able to eat 3/4 of the circle. So, Evelyn, can you explain how you guys found the
So what
area
we
then?
did was we first found the whole area of the triangle, and after that, once we found the area of the triangle, we divided that by 4 and multiplied it by 3 because there would be, we divided basically the area of the circle into 4 parts, and then since there's only 3/4, we multiplied the 1/4 of the part times 3, and we got 21 and 2100 yards squared that he can.
Okay, so instead of a triangle, it's really the other part of the circle here. It's not really a triangle because it's not a straight side, right? So you said that you had an entire circle and you took away 1/4 of it, right? So you took the circle and divided it into 4 parts, okay? So you did pi times radius squared and divided it into 4 parts. And then what happened when you divided it into 4?
Well, it would be, we multiplied by 3.
Okay, and then you multiplied it by 3 since there's actually 3 of the 4 parts. Okay, and you got, what was your answer?
21 and 2100 yards.
Okay. Did any group do it differently? Casey?
So what we did is we like completely measured it out and made the circle completely equal.
Okay.
And then what we did was from the point where he was like hooked up to one point on the outside, we found that the radius was 3 yards.
Okay.
And then since to find an area you need to do pi times radius squared, so we did 3 times 3, which is 9, and then 9 times pi is 28.26. And then since it was only 3/4 of a circle, we since 25 was 104 times, we multiplied it by 0.75, which is basically like multiplied by 2/4, and we got 21.195 yards.
Okay, so you took the area formula and then multiplied it by 3/4, right? Or 0.75. And you got what, Casey? I'm sorry?
21.195.
Okay. Did any group do it differently? So we had one group who found the whole circle and then minus 1/4 of the circle essentially, and we had another group, and maybe other groups that I walked around to as well, that just noticed that this was 3/4 of a circle, so they just multiplied the area of a circle times 3/4. Okay. Are these answers close? And remember, some of our answers are going to differ anyway because if you use the pi button on the calculator, or if you use 3.14 in the calculator, our answers may be a couple hundredths or tenths off. But they are in the ballpark, so I would assume that both of the answers, if used pi or if used 3.14, would be the same. Good. All right, so what are some strategies, because we're running out of time here, what are some strategies that we are actually working on in order to find this last part, the super challenge of this activity? Any strategies you guys have come up with? Maybe you haven't had time to implement it yet.
Kind of like a guess and check, like, this doesn't work, then maybe this does.
Okay? Just based on the area that we found already, if he's only able to eat 10 square yards, is that going to be more or less than he had before? It's almost half less, right? Which means that he's probably going to have have a shorter rope than 3 yards to use, right? So maybe a good estimate, like Leah said, she might use guess and check. A good guess and check might be to start using half the size of the rope, okay? All right, so we're going to revisit this piece with the groups that you're in now. So go ahead and let's start cleaning up your supplies, get your final thoughts down, and if we could have one person from each group